Welcome to the deep dive. We're the show that helps you cut through all that noise, and really get the insights you need on complex
Yeah,
topics.
there's just so much information out there.
Exactly. And our mission is always to give you that shortcut to being properly informed. Today, we're diving into something that looks like a real game changer in AI development.
Hmm.
Amazon Bedrock AgentCore Runtime. It's a new thing designed to tackle some of those big headaches developers hit when they're trying to bring AI agents to life.
That's right. And our goal today is really to unpack it. What is Amazon Bedrock Agent Core Runtime? Why is it such a big step forward for developers building these agents? And, how does it actually make it easier to get these things running without getting totally bogged down?
Right. We've gone through the tech docs, the SDK details, all that stuff to try and give you the clearest picture possible.
Make it engaging, not just dry docs.
Yeah, exactly. So by the end of this, you should have a really solid grasp of this tech, some memorable bits, maybe some actionable stuff too, and hopefully at a pace that works for you.
Okay.
So let's get into it. What is Amazon Bedrock Agent Core Runtime, and why should developers, building AI agents actually care about this?
Okay. So at its heart, Amazon Bedrock Agent Core Runtime is basically a secure serverless runtime. It's
Yeah.
specifically built for deploying and scaling these dynamic AI agents and, the tools they use.
Okay, serverless runtime.
Yeah, think of it like a universal adapter for your agents. It's the engine running behind the scenes that's supposed to make deploying these things, well, as smooth as possible.
A universal adapter.
That sounds ambitious. I remember years back trying to get different frameworks to play nice. It was a nightmare, like trying to translate between two OECs that don't speak the same language.
Right.
So how does this actually help a developer in practice? What makes it universal?
Well, that's where it gets really interesting. First off, it's framework agnostic,
Sure.
meaning it supports basically any open source framework you might be using, the popular ones like LangChain, LangGraph, Crew AI, even Amazon's own Strands agents.
Ah, okay. So you're not locked in. Exactly. You're not locked into one way of building. And it's flexible with protocols, too, works with any protocol, things like MCP, A2A, so it should interoperate widely.
Hmm.
And here's a really big one. It's model provider neutral.
Ah, so you can use models from anywhere.
Pretty much.
Yep.
Any large language model from any provider, Amazon Bedrock itself, obviously, but also OpenAI, Gemini, others. It means it can run really any type of agent you build, multimodal, real-time, or maybe like a long-running background task.
Okay, so it really is aiming to be this sort of universal launchpad. It handles the tough stuff, security, scaling, integration for almost any AI agent you can think of.
That's the idea, precisely. And that leads right into the core benefits, like why this really matters day to day for developers.
Right.
First big one, security. It gives you complete session isolation. It does this using dedicated micro VMs.
Micro VMs, like tiny virtual machines.
Yeah, exactly. Tiny isolated virtual machines, like a sandbox for each user session.
Oh.
And that's absolutely critical if your agent is handling sensitive data or performing privileged actions for a user.
Makes sense. You need that separation.
Totally. Then there's scalability. It can apparently scale up to thousands of agent sessions in just seconds,
Wow.
which means developers hopefully don't have to stress about managing the underlying infrastructure for that.
Yeah, it's huge.
Reliability is another piece. It has session persistence built in. So your agent state should stick around, even if there are like temporary network hiccups or something.
Okay.
And it's cost effective. It's a pay for what you use model, not paying for idle servers.
Standard cloud benefit, but always good.
Right. And finally, identity integration. This is pretty neat. It works with the major identity providers, Amazon Cognito, Microsoft Entra ID, Okta,
The big ones?
yeah, and also popular OAuth providers like Google, GitHub. And it supports all the ways you might authenticate OAuth tokens, simple API keys, or even AWS IAM roles for more fine-grained control.
That identity piece sounds really useful, actually, much less boilerplate to write. Now, you did mention earlier this is currently in a preview release, right?
Yes. Good point. That's really important context.
So what does preview mean in practice for someone thinking about using this?
It means, well, it means things could still change. The APIs might evolve, features might be added or altered. It's generally not recommended for your most critical production systems just yet, where absolute stability is paramount.
Okay.
But it's a fantastic time to start experimenting, building things out, giving feedback. You get a head start for when it does become generally available.
Got it. So stable enough to explore, maybe not for the crown jewels just yet. Okay, so if you're listening, you're thinking, yeah, this could solve some of my deployment pain. What do you actually need to get started, and what are these deployment paths you mentioned?
Okay, prerequisites first. Pretty straightforward.
Mm-hmm.
You need an AWS account, obviously, with the right permissions set up. You'll need Python 3.10 or newer, and it helps to be familiar with Docker containers,
Yeah.
especially if you want to go down the more advanced path.
Okay. Standard stuff for cloud dev mostly.
Pretty much. Then you've got two main ways to deploy. Option A is called SDK integration, and option B is custom agent. Choosing between them is actually a key decision based on what you need.
All right, let's break those down. What's option A, SDK integration, good for?
Hmm.
Who's that aimed at?
Option A is really your fast track. It's ideal if you want to quickly wrap up existing agent functions and deploy them.
Okay.
Think simple agents, rapid prototyping, situations where you want the minimum possible setup fuss.
Okay, the quick path. What are the pros and cons?
The big pro is convenience. You get an HTTP server set up for you automatically, and there are built-in deployment tools. Makes things really easy. The trade-off is, well, you have less direct control over that server configuration because it's managed for you.
And how easy is setup, like code-wise?
Pretty simple. You just pip install Bedrock AgentCore. Then in your Python code, you use a decorator at app.entryPoint to basically point the runtime at your main agent function.
Yeah.
And even within option A, you have choices for deployment. There's a starter toolkit, which is super automated. You just run a command like AgentCore launch, and boom, you're prototyping.
Nice.
Or if you need a bit more control but still want the SDK benefits, you can do a manual deployment with Boto 3. That involves packaging your code into a container image, pushing it to ECR, that's Amazon's Elastic Container Registry, and then using the AWS SDK, Boto 3, to call Create Agent Runtime.
Right, so still using the SDK server, but managing the deployment yourself more directly.
Exactly. Gives you more control over the deployment process itself.
Okay, that sounds like a really solid option for getting started quickly or for simpler use cases. But what if you need, like, total control? Or you're building something really complex? That must be option B, the custom agent approach.
That's it, exactly. Option B, custom agent, is for when you need full control over the agent's HTTP interface. Maybe you have a very complex agent, you need to plug in custom middleware, or it's a production system where you need that really fine-grained control over everything.
And the benefits there are obviously that control, right? Custom routing, advanced features.
Complete fast API control, yeah.
Yeah.
You build the web server part exactly how you need it.
Yeah.
The trade-off, of course, is more work. You have to do more setup, configure the server manually.
Makes sense. Are there specific technical requirements for option B?
Yes, a few key ones. You must provide a fast API server. Your server needs to have a POST endpoint at invocations. That's where the runtime sends requests to your agent.
Mm.
And it needs a geeky endpoint at ping for health checks.
Standard practice for microservices, sort
Yeah.
of?
And crucially, the whole thing needs to be packaged as an ARM64 Docker container image.
ARM64. Okay, that's important. So it sounds like you've got this fast lane with SDK integration and then this custom highway with option B. How does a developer actually choose? Beyond just simple versus complex, what's the strategic thought there?
That's a really good question. It boils down to control versus convenience,
Right.
fundamentally. If your agent needs to deeply integrate into an existing system, maybe it needs custom authentication logic that the SDK doesn't handle out of the box. Or it needs to talk to some specific internal API with weird HTTP requirements. Option B gives you the total freedom to build that.
Okay.
But if you're building something new, maybe a standalone agent, or you're just trying to get an idea out fast, and the standard HTTP setup provided by option A works for you, then that's going to get you running much, much quicker. It's really optimizing for speed versus that deep customization.
Got it. That clarifies the choice nicely. Now, something that jumped out in the docs was this big warning. Don't forget observability. Why is observability so critical, especially for these AI agents?
Oh yeah, that's super important. Not an afterthought at all. Observability gives you the built-in metrics, the spans, the traces, basically the visibility you need to monitor your agents effectively using CloudWatch, which is AWS's monitoring service.
So it lets you see what the agent is actually doing.
Exactly. It's essential for understanding performance, how it's behaving in the real world, even for tracking down bugs. Without it, your agent could be failing silently or maybe not performing well, and he'd be flying blind. You get those horrible, it works on my machine, or black box problems.
All right, the black box problem, definitely want to avoid that with AI. So how do you actually enable this observability? What are the steps?
It's a couple of things. First, there's a one-time setup. You need to enable CloudWatch transaction search.
Okay.
You can do this pretty easily in the AgentCore console. When you're setting up a memory resource, there's usually an Enable Observability button. Click that.
Or manually.
Or you can do it manually in the main CloudWatch console. You'd go to Application Signals, find Transaction Search, click Enable Transaction Search, and this is important. Tick the box that says something like ingest spans as structured logs. That turns on the capability for CloudWatch to understand the trace data.
Okay, one-time setup. Done.
Right.
What's next for the agent code itself?
Right. Step 2 is adding ADOT to your agent. ADOT is the AWS distro for OpenTelemetry. It's an open standard for observability data.
Oh, OpenTelemetry, okay.
Yeah. So you add a couple of dependencies to your Python project. OS's OpenTelemetry distro and Boto 3. Then when you run your agent's Python script, you run it using auto instrumentation. Usually this means putting OpenTelemetry instrument before your normal Python urgent script.py command.
So it injects the monitoring code automatically.
Pretty much, yeah. It handles a lot of the standard stuff for you. Now, for tracing specific user interactions across multiple steps or calls, which is super useful, you need to propagate a session ID. You can do this using the OpenTelemetry baggage feature.
Baggage, yeah.
It's a way to carry context along with the requests. And for even richer traces, you can also pass specific HTTP headers when you invoke the agent, like XM's in traceHead, traceParent, the Bedrock-specific session ID header, and that baggage header again. These give CloudWatch more hooks to tie everything together.
Gotcha. So enable the backend, instrument the code, pass some IDs. Then where do you actually see all this useful data?
You go back to the CloudWatch console. There's a specific GenAI observability page now. You find your agent service there, and you can drill down into the traces, see the metrics, look at the logs. It gives you that whole picture of what's happening.
Okay. And any tips for making the most of this? Best practices for observability.
Definitely. Use consistent session IDs. Seriously, it makes debugging multi-step interactions infinitely easier. Like trying to follow a conversation, you need to know who's talking.
Right.
Set appropriate sampling rates.
Yeah.
You probably don't need to trace every single request in high volume. The default is often low, like 1%. Find a balance that gives you insight without overwhelming you or costing too much. Monitor the key metrics. Things like latency, how fast is it responding, error rates, is it failing often, maybe even token usage if you're watching costs closely. And finally, set up CloudWatch alarms for critical thresholds on those metrics. That way you get notified before a small issue becomes a big problem. It's about being proactive.
So it's really moving beyond just building and launching, isn't it? It's about having that continuous visibility, understanding what your agent is doing out there. That feels essential for anything beyond a simple toy project.
Absolutely essential. You need that feedback loop to maintain and improve these things, especially as they get more complex. It's how you go from prototype to a reliable production service.
Okay, so we've covered the two deployment options, the importance of observability. Are there any requirements or practices that apply sort of across the board, regardless of which path you take?
Yeah, there are a few core things that apply to both Option A and Option B. Your agent must run on a Linux ARM64 platform.
We mentioned ARM64 before, yeah.
Both the invocation's PST endpoint and the ping ET endpoint are mandatory. The runtime needs those to interact with your agent and check its health.
Okay.
Your container images have to be stored in Amazon ECR. Your application inside the container needs to listen on port 8080. It uses Strands agent, or integrates with it, for the AI processing part. And of course, it needs AWS credentials configured correctly to operate.
Got it. And just general good advice for developers working with this. Best practices to avoid common pitfalls.
Yeah, standard but crucial stuff.
Mhm.
For development, test locally first. Don't just throw it at the cloud. Use version control, Git, whatever.
Mhm.
You will need to roll back or track changes. Keep your dependencies up to date. Security patches, performance fixes, all that.
Makes sense. What about configuration and security?
For config, use IAM roles with the least privilege principle. Don't give your agent permissions it doesn't absolutely need. Implement proper error handling in your agent code. Don't let it just crash silently. And monitor performance using those observability tools we talked about. Security-wise, be careful with sensitive information. Use tools like AWS Secrets Manager maybe, don't hard-code secrets, and do regular security updates on your container images and dependencies.
And if things go wrong. Troubleshooting 101.
Check the basics first. Are your AWS credentials correct and working? Does the IAM role have the necessary permissions? Is Docker actually running on your local machine? If you're testing there, look at the CloudWatch logs. They often tell you exactly what's wrong. And again, test locally before you deploy. Saves a lot of hassle.
Solid advice. Okay, so wrapping this up then, it really feels like Amazon Bedrock AgentCore Runtime is trying to offer this significantly streamlined path for deploying these dynamic AI agents. Doesn't matter so much what framework or model you use,
Yeah.
that mix of flexible deployment, taking care of scaling and security, and then adding that crucial observability layer. It seems like a powerful combination aimed right at solving those common developer frustrations.
I think that's the goal, absolutely. It's about empowering developers to, focus their brain power on the agent's actual logic, its intelligence, the unique problem it's solving.
Rather than wrestling with infrastructure.
Exactly. Less time on the plumbing, more time on the innovation. That's the promise, anyway.
Right. So maybe a final thought for you listening. As these AI agents get smarter, more capable, and start doing more complex, maybe even personalized tasks for us,
Hmm.
how might these kinds of serverless runtimes like Bedrock Agent Core Runtime fundamentally change how we interact with AI? Are we moving beyond just asking simple questions towards, I don't know, more dynamic, task-focused collaborations with AI?
Hmm. That's a really interesting question to think about, from simple queries to genuine collaboration.
Yeah.
Definitely something to ponder.